fossils and how they are formed. How of 1,000 snakes each one was changed into a coil of stone. Fossils are the remains, or even the indications, of animals and plants that have, through natural agencies, been buried in the earth and preserved for long periods of time. This may seem a rather meager definition, but it is a difficult matter to frame one that will be at once brief, exact, and comprehensive. Fossils are not necessarily the remains of extinct animals or plants. Neither are they, of necessity, objects that have become petrified or turned into stone. Bones of the great auk and rhytina, which are quite extinct, would hardly be considered as fossils, while the bones of many species of animals, still living, would properly come in that category, having long ago been buried by natural causes and often been changed into stone. And yet it is not essential for a specimen to have had its animal matter replaced by some mineral in order that it may be classed as a fossil, for the Siberian mammoths, found entombed in ice, are very properly spoken of as fossils, although the flesh of at least one of these animals was so fresh that it was eaten. Likewise, the mammoth tusks brought to market are termed fossil ivory, although differing but little from the tusks of modern elephants. Many fossils indeed merit their popular appellation of petrifications because they have been changed into stone by the slow removal of the animal or vegetable matter present and its replacement by some mineral, usually silica, or some form of lime. But it is necessary to include indications of plants or animals in the above definition, because some of the best fossils may be merely impressions of plants or animals, and no portion of the objects themselves. And yet, as we shall see, some of our most important information has been gathered from these same imprints. Nearly all our knowledge of the plants that flourished in the past is based on the impressions of their leaves, left on the soft mud or smooth sand that later on hardened into enduring stone. Such, too, are the trails of creeping and crawling things, casts of the burrows of worms, and the many footprints of the reptiles, great and small, that crept along the shore or stalked beside the waters of the ancient seas. The creatures themselves have passed away, their massive bones even are lost, but the prints of their feet are as plain today as when they were first made. Many a crustacean, too, is known solely or mostly by the cast of its shell, the hard parts having completely vanished, and the existence of birds in some formations is revealed merely by the casts of their eggs. And these natural casts must be included in the category of fossils. Impressions of vertebrates may indeed be almost as good as actual skeletons, as in the case of some fishes, where the fine mud in which they were buried has become changed to a rock, rivaling porcelain in texture. The bones have either dissolved away or shattered into dust at the splitting of the rock, but the imprint of each little fin ray and every thread-like bone is as clearly defined as it would have been in a freshly prepared skeleton. So fine indeed may have been the mud, and so quiet for the time being the waters of the ancient sea or lake, that not only have prints of bones and leaves been found, but those of feathers and of the skin of some reptiles, and even of such soft and delicate objects as jellyfishes. But for these we should have little positive knowledge of the outward appearance of the creatures of the past, and to them we are occasionally indebted for the solution of some moot point in their anatomy. The reader may possibly wonder why it is that fossils are not more abundant. Why, of the vast majority of animals that have dwelt upon the earth since it became fit for the habitation of living beings, not a trace remains? This too, when some objects, the tusks of the mammoth for example, have been sufficiently well preserved to form staple articles of commerce at the present time, so that the carved handle of my lady's parasol may have formed part of some animal that flourished at the very dawn of the human race, and been gazed upon by her grandfather 1,000 times removed. The answer to this query is that unless the conditions were such as to preserve at least the hard parts of any creature from immediate decay, there was small probability of its becoming fossilized. These conditions are that the objects must be protected from the air, and practically the only way that this happens in nature is by having them covered with water or at least buried in wet ground. If an animal dies on dry land, where its bones lie exposed to the summer's sun and rain, and the winter's frost and snow, it does not take these destructive agencies long to reduce the bones to powder. In the rare event of a climate devoid of rain, mere changes of temperature by producing expansion and contraction will sooner or later cause a bone to crack and crumble. Usually, too, the work of the elements is aided by that of animals and plants. Everyone has seen a dog make way with a pretty good-sized bone, and the hyena has still greater capabilities in that line. And ever since vertebrate life began, there have been carnivorous animals of some kind to play the role of bone destroyers. Even were there no carnivores, there were probably then, as now, rats and mice aplenty, and few suspect the havoc small rodents may play with a bone for the grease it contains, or merely for the sake of exercising their teeth. Now and then we come upon a fossil bone, long since turned into stone, on which are the marks of the little cutting teeth of field mice, put there long ago, and yet looking as fresh as if made only last week. These little beasts, however, are indirect rather than direct agents in the destruction of bones by gnawing off the outer layers and thus permitting the more ready entrance of air and water. Plants, as a rule, begin their work after an object has become partly or entirely buried in the soil, when the tiny rootlets find their way into fissures, and expanding as they grow, act like so many little wedges to force it asunder. Thus, on dry land there is small opportunity for a bone to become a fossil. But if a creature so perishes that its body is swept into the ocean or one of its estuaries, settles to the muddy bottom of a lake, or is caught on the sandy shoals of some river, the chances are good that its bones will be preserved. They are poorest in the ocean, for unless the body drifts far out and settles down in quiet waters, the waves pound the bones to pieces with stones or scour them away with sand, while marine worms may pierce them with burrows, or echinoderms cut holes for their habitations. There are more enemies to a bone than one might imagine. Suppose, however, that some animal has sunk in the depths of a quiet lake, where the wash of the waves upon the shore wears the sand or rock into mud so fine that it floats out into still water and settles there as gently as dew upon the grass. Little by little, the bones are covered by a deposit that fills every groove and pore, preserving the mark of every ridge and furrow. And while this may take long, it is merely a matter of time and favorable circumstance to bury the bones as deeply as one might wish. Scarce a reader of these lines, but at some time has cast anchor in some quiet pond and pulled it up, thickly covered with sticky mud, whose existence would hardly be suspected from the sparkling waters and pebbly shores. If, instead of a lake, our animal had gone to the bottom of some estuary into which poured a river turbid with mud, the process of entombment would have been still more rapid, while, had the creature been engulfed in quicksand, it would have been the quickest method of all. And just such accidents did take place in the early days of the earth as well as now. At least 2 examples of the great dinosaur Thespesius have been found with the bones all in place, the thigh bones still in their sockets and the ossified tendons running along the backbone as they did in life. This would hardly have happened had not the body been surrounded and supported so that every part was held in place and not crushed. And it is difficult to see any better agency for this than burial in quicksand. If such an event as we have been supposing took place in a part of the globe where the land was gradually sinking and the crust of the earth is ever rising and falling, the mud and sand would keep on accumulating until an enormously thick layer was formed. The lime or silica contained in the water would tend to cement the particles of mud and grains of sand into a solid mass, while the process would be aided by the pressure of the overlying sediment, the heat created by this pressure, and that derived from the earth beneath. During this process, the animal matter of bones or other objects would disappear, and its place be taken by lime or silica, and thus would be formed a layer of rock containing fossils. The exact manner in which this replacement is effected, and in which the chemical and mechanical changes occur, is very far from being definitely known, especially as the process of fossilization must, at times, have been very complicated. In the case of fossil wood, greater changes have taken place than in the fossilization of bone, for there is not merely an infiltration of the specimen, but a complete replacement of the original vegetable by mineral matter, the interior of the cells being first filled with silica and their walls replaced later on. So completely and minutely may this change occur that under the microscope the very cellular structure of the wood is visible, and as this varies according to the species, it is possible, by microscopical examination, to determine the relationship of trees in cases where nothing but fragments of the trunk remain. The process of fossilization is at best a slow one, and soft substances such as flesh or even horn decay too rapidly for it to take place, so that all accounts of petrified bodies, human or otherwise, are either based on deliberate frauds or are the result of a very erroneous misinterpretation of facts. That the impression or cast of a body might be formed in nature, somewhat as casts have been made of those who perished at Pompeii, is true. But so far, no authentic case of the kind has come to light, and the reader is quite justified in disbelieving any report of a petrified man. Natural casts of such hard bodies as shells are common, formed by the dissolving away of the original shell after it had become enclosed in mud, or even after this had changed to stone, and the filling up of this space by the filtering in of water charged with lime or silica, which is there deposited, often in crystalline form. In this way, too, are formed casts of eggs of reptiles and birds, so perfect that it is possible to form a pretty accurate opinion as to the group to which they belong. Sometimes it happens that shells or other small objects embedded in limestone have been dissolved and replaced by silica, and in such cases it is possible to eat away the enveloping rock with acid and leave the silicified casts. By this method, specimens of shells, corals, and bryozoans are obtained of almost lace-like delicacy and as perfect as if only yesterday gathered at the seashore. Casts of the interior of shells, showing many details of structure, are common, and anyone who has seen clams dug will understand how they are formed by the entrance of mud into the empty shell. Casts of the kernels of nuts are formed in much the same way, and Professor E.H. Barber has thus described the probable manner in which this was done. When the nuts were dropped into the water of the ancient lake, the kernel rotted away, but the shell, being tough and hard, would probably last for years under favorable circumstances. Throughout the marls and clays of the Badlands of South Dakota, there is a large amount of potash. This is dissolved by water and then acts upon quartz, carrying it away in solution. This would find its way by infiltration into the interior of the nut. At the same time with this process, carrying lime carbonate in solution was going on, so that doubtless the stone kernels, consisting of pretty nearly equal parts of lime and silica, were deposited within the nuts. These kernels, of course, became hard and flinty in time and capable of resisting almost any amount of weathering. Not so the organic shell. This eventually would decay away and so leave the filling or kernel of chalcedonian lime. Footnote: right here is the weak spot in Professor Barber's explanation, and an illustration of our lack of knowledge, for it is difficult to see why the more enduring husk should not have become mineralized equally with the cavity within. End of footnote. Fossil leaves are nothing but fine casts made in natural molds, and all have seen the first stages in their formation as they watched the leaves sailing to the ground to be covered by mud or sand at the next rain, or dropping into the water where, sooner or later, they sink, as we may see them at the bottom of any quiet woodland spring. Impressions of leaves are among the early examples of color printing, for they are frequently of a darker or even different tint from that of the surrounding rock, this being caused by the carbonization of vegetable matter or to its action on iron that may have been present in the soil or water. Besides complete mineralization or petrification, there are numerous cases of incomplete or semi-fossilization, where modern objects, still retaining their phosphate of lime and some animal matter even, are found buried in rock. This takes place when water containing carbonate of lime, silica, or sometimes iron, flows over beds of sand, cementing the grains into solid but not dense rock, and at the same time penetrating and uniting with it such things as chance to be buried. In this way was formed the fossil man of Guadalupe, West Indies, a skeleton of a modern Carib lying in recent concretionary limestone, together with shells of existing species and fragments of pottery. In a similar way, too, human remains in parts of Florida have, through the infiltration of water charged with iron, become partially converted into limonite iron ore. And yet we know that these bones have been buried within quite recent times. Sometimes we hear of springs or waters that turn things into stone, but these tales are quite incorrect. Waters there are, like the celebrated hot springs of Auvergne, France, containing so much carbonate of lime in solution that it is readily deposited on objects placed therein, coating them more or less thickly according to the length of time they are allowed to remain. This, however, is merely an incrustation, not extending into the objects. In a similar way, the precipitation of solid material from waters of this description forms the porous rock known as tufa, and this often encloses moss, twigs, and other substances that are in no way to be classed with fossils. But some streams, flowing over limestone rocks, take up considerable carbonate of lime, and this may be deposited in water-soaked logs, replacing more or less of the woody tissue and thus really partially changing the wood into stone. The very rocks themselves may consist largely of fossils. Chalk, for example, is mainly made up of the disintegrated shells of simple marine animals called foraminifers, and the beautiful flint-like skeletons of other small creatures termed radiolarians, minute as they are, have contributed extensively to the formation of some strata. Even after an object has become fossilized, it is far from certain that it will remain in good condition until found, while the chance of its being found at all is exceedingly small. When we remember that it is only here and there that nature has made the contents of the rocks accessible by turning the strata on edge, heaving them into cliffs or furrowing them with valleys and canyons, we realize what a vast number of pages of the fossil record must remain not only unread, but unseen. The wonder is not that we know so little of the history of the past, but that we have learned so much, for not only is nature careless in keeping the records, preserving them mostly in scattered fragments, but after they have been laid away and sealed up in the rocks, they are subject to many accidents. Some specimens get badly flattened by the weight of subsequently deposited strata. Others are cracked and twisted by the movements of the rocks during periods of upheaval or subsidence, and when at last they are brought to the surface, the same sun and rain, snow and frost from which they once escaped are ready to renew the attack and crumble even the hard stone to fragments. Such, very briefly, are some of the methods by which fossils may be formed. Such are some of the accidents by which they may be destroyed. But this description must be taken as a mere outline and as applying mainly to vertebrates, or backboned animals, since it is with them that we shall have to deal. It may, however, show why it is that fossils are not more plentiful, why we have more hints of the existence of many animals, and why myriads of creatures may have flourished and passed away without so much as leaving a trace of their presence behind. References: A very valuable and interesting article by Dr. Charles A. White, entitled "The Relation of Biology to Geological Investigation," will be found in the report of the United States National Museum for 1892. This comprises a series of essays on the nature and scientific uses of fossil remains, their origin, relative chronological value, and other questions pertaining to them. The United States National Museum has published a pamphlet, Part K, Bulletin 39, containing directions for collecting and preparing fossils by Charles Schuchert, and another, Part B, Bulletin 39, collecting recent and fossil plants by F. H. Knowlton. End of Chapter 1.